Okay, so in this video, I want to look at the volume of revolution of a sphere by revolving a circle. And what I'm going to do is I'm going to look at taking a relatively easy circle where I'm going to take the circle with equation x squared plus y squared equals r squared. So that's the circle center, the origin, radius r. And so if I just draw the top part of the circle, then this coordinate will be minus r, this coordinate will be r. And of course, we want the volume of a sphere to be 4/3 pi r cubed. That's the formula for the volume of a sphere, and we want to obtain that by a volume of revolution. So I'm going to essentially take this shape and revolve it, okay? Now, the first thing to realize is that we need to use the formula. The volume of revolution is pi, and then if we want to revolve about the x-axis, we would need y squared dx, and in this case, the x values are going to be from minus r to r, but I'll call them x1 and x2 for the moment, okay? So it's going to be, we'll see that in a moment. Okay, so here, if we rearrange, we get y squared equals r squared minus x squared. And if we square root, we get y equals plus or minus the square root of r squared minus x squared. And now, what I want you to note is that the top bit here has equation y equals the positive square root of r squared minus x squared. And if we wanted the bottom part of the circle, that would have the equation y equals minus r squared minus x squared square rooted, okay? So the bit that we want is just a positive one, but we're revolving. Or we could use a negative one, it actually wouldn't make any difference in this case. So in here, we're gonna get, let me go back to black. Here we're gonna get pi, and then move over to this side actually, pi times the integral from minus r to r of y squared. Now y squared we can see is r squared minus x squared, r squared minus x squared dx. And if we integrate that, we're going to get pi, and then the integral of r squared, where r squared is a constant, is r squared x. Remember, x is the variable here. And the integral of x squared is 1/3 x cubed, okay? So r is a constant, and from constant value minus r to constant value r. And so if we now substitute it in r, we get pi, putting in r, we get r cubed, minus putting in r 1/3 r cubed, and putting in minus r, we get minus r times r squared is minus r cubed, and putting in minus r, we get plus 1/3 r cubed, because there are 4 negatives inside this bracket. 1 negative from the minus 1/3, 3 negatives from minus r being cubed, which gives us a plus 1/3 r cubed. And then if we calculate that, the first bracket is going to be 2/3 r cubed, and the second one is actually minus 2/3 r cubed. It's going to be plus 2/3 r cubed, and so the whole thing is 4/3. Just write that a bit more neatly. 4/3 pi r cubed, which is what we wanted to prove. Proofs are normally ended by a rectangle, as I've done there, or quoad demonstrandum, or quite easily 10, as we sometimes say. Okay, I hope you can see how easy that was. I was asked about the volume of revolution of a circle that doesn't produce a sphere but produces a torus or a donut shape, I think that will be possible to do in the second year when we have done second year calculus. So remind me about that if you're interested. So for the moment, that's it.